Hey everybody, this video is going to be about something called a piecewise function, or they call them piecewise defined function. And the notation looks a little bit tricky, but I'm going to try to make it as simple as I can. I'm going to do one by hand. I'm going to use the sketch pad. It's going to look kind of sloppy, probably because I don't really have a graph in the sketch pad, but I'm going to put, I'm going to use Desmos for this one too, to show you how really well it does it. But there's one little thing we got to be careful with, and I'll show you what that is. All right, so let's get to it here. All right, a piecewise defined function looks like this. Here's an example of one of them. And to make this simple as I can, every year I've tried to explain this different ways, and the best way to look at this is like this is two different functions in a way. It's one big function together, but it's defined in two separate pieces. That's why it's called piecewise. All right. Now, what this is, first, this is 4 minus x, which is a linear function. It's got a slope of -1, y-intercept of 4 usually, if it goes there. All right. And this is telling you where the domain of that piece is allowed to be. So this is the piece where the domain of x is less than 2. All right. This is another piece of linear function. Slope of 2, y-intercept -6, that's an mx plus b. And he lives if x is greater than or equal to 2. Right? So he includes 2, he doesn't include 2. They can't both include 2. If it did, it wouldn't pass a vertical line test. Okay? So it wouldn't be a function. All right, so this thing is not too bad of one. I'm going to graph it for you by hand here. And I'll show you kind of how to think of it. Then I'll show you a Desmos way to do it, okay? All right, so I've already written it on my sketch pad here. And one way to do this is just piece by piece construct this function. And if I can draw a decent axis here. Getting lucky there. Sometimes working in this sketch pad, just drawing straight lines is really not easy. So there's our x-axis and our y-axis. And we'll talk my way through this one. In the next one, I'll try to show you a shortcut with Desmos to make it really easy. All right, so we're supposed to graph 4 minus x if x is less than 2. All right, so I know I can't go anywhere to the right of 2. So this is it's got a -1 slope, y-intercept at 4. That helps me graph it, right, because it does live there. So we'll go up to 4, and we know we have a y-intercept there, right? And then I have a slope of down 1, over 1, and all that good stuff. But the problem is I need to know where it starts. And I know I can't really put 2 in here, but I can kind of cheat and say, hey, what is happening at 2? So I'm going to put 4 minus 2, and I get functions at 2, right? Now it can't really exist there because it says it's less than 2 strictly. So I got to use an open circle. So that'll be an open circle, and then I would connect the dots. And I'm being really careful, trying to make it look straight, and that's about the best I can do, and it would go on infinitely in that direction. So there is a piece of it right there. Normally this is the line that would just come straight through and cut the plane in half, but it's got a domain restriction that says, hey, you got to be to the left of 2, and I can't even include 2, right? That's what the open circle is. All right, the next one is this 2x minus 6. And as you can see, it's really important to know what's happening at 2. So we're going to find out. We're going to say, okay, what is going on at 2? So 2 times 2 minus 6 is actually -4 this time. So, but I can include that point. So at 2, I've got a -4, 3, 4, and it would be a solid circle right here, okay? Now, to get your other points, now some of you are going to run into this in Delta Math, that's why I'm showing you how to get your other points. So you need to know your start-stop points, include or not include, use these, and then you might want to realize it says linear on the slope of the line, where I would go up 2, right, over 1, and I realize this is a very crude graph, but I'm just doing my best here with what I've got to work with. And then you would connect your dots, and this would look something like that, okay? So that's a hand-sketched graph. If it was on graph paper, it'd really be fantastic, but we had to do the best with what we have. Now, before this video gets too long, let me show you how nice Desmos is with this, okay? You still got to know how to plot them to put them into your assignment in Delta Math, but you can at least get a really nice looking graph. So I've already entered these into a Desmos. Don't look at all of them. They look daunting together. So what I do is I know there's a better way to do this or another way, but this is the way I know to do it for now, is you put each piece of the function in. In other words, there is my 4 minus x piece, right? There's that y-intercept at 4, that slope of -1, right, down 2, over 2. And then there's that domain restriction for that piece. Don't forget these braces or brackets, whatever you want to call them, and type that inequality in just like it looks. But you got to use those little braces, and it will work. Let's turn on the other part. That'll both turned off, and there's your piecewise function. Now, somebody might be saying, well, Mr. Ellis, the open circles and closed circles are confusing me. If you enter this just like it looks, Desmos will actually give you that open circle. See that? It says it's undefined there. It doesn't exist there. All right? There is no output value there. So that it literally shows you the open circle. Come over here. This one, that's not completely on it. You got to get it right on that point there. Is the best. There it is. And notice it shows you a solid circle there, right? Down to the end. I didn't know you could do that. So I learned something just now. Look at that. Yep. So you can just slide this up and down the line. All right. So it tells you it's undefined open circle. This one tells you it's solid circle. All right. So that's that one. All right. So that's how you would graph a piecewise function. Literally each piece at a time. So let's go back here and look at this other one. And I don't want to spend a lot of time on it because I got some other skills to put in these videos. Right now we're just talking about how do you graph these things. Now this guy looks really complicated and nasty, but let's take it apart for a second. Then we'll just put it in Desmos. I won't do this one by hand. This is this piece, when we're talking the piece right here, this is the linear piece, 2x plus 8. Y-intercept 8, slope of 2, starts at -2, right? X squared minus 3. Now this is a parabola shifted down 3 units. Starts at -2, goes to 3. This is the square root function that's greater than 3, so there's 3 little pieces. And I'll show you in Desmos what that looks like. I'm going to turn these off. The linear piece. Notice it should have a solid circle. And it does. And that tells you the endpoint. Makes it super easy. Here comes the quadratic piece, or the parabolic piece. Right? It's right here. Oh, it says open circle. Don't include that point. Closed circle, include that point. And finally, our square root piece is right here. And are we including that point? No, we're not. And that's exactly right. You guys, it can't get much easier than this. You got to use Desmos. You can't forget these braces. That's what really makes it easy, okay? Well, I'll see you in the next video. We're going to talk about how to evaluate these. And you know what? I may use some of this Desmos. I'm not sure yet. It might make it really easy. But I'll see you in the next video.